Our next speaker is Gianfranco Alongi, who's a senior software engineer for Ericsson, and he's the founder of the software craftsmanship community in Stockholm. So that's his credentials. Now here's the real story. Watch this man. He's a tornado. I know two stories about it. I first met Gianfranco at Iverson College. He's a relative newcomer to APL, but he impressed Phil last. Wow. And Phil looked at some of the code Gianfranco was producing, and Phil said to me, many of the people in this room would not have thought of that. So that's one story. And the other one is Morten told me a story that Morten had, I think the first contact Gianfranco had with APL was at one of Morten's lectures. And Morten suggested people go to the Try APL website to try experimenting with APL. And in a matter of moments, I think, very shortly, Gianfranco had come back to Morten and said, I think you have a problem with monadic comma bar, which turned out to be true. So watch this man.
Thank you. Okay, so before I delve into the TDD, I just would like to mention that I have a diverse background. And I am not here as an APL expert, obviously. I'm here to learn from you. You are the experts in APL. But I hope to bring something to you, something from the outside. I perceived it that the APL community is a tad closed. So this is a chance to get something in return for me being here. So TDD, it is test-driven development. What is TDD? Test-driven development is a practice that turns testing into a design activity. And here it is very important to differentiate between design and implementation. So designing is where you are thinking about how something will be built. And then the implementation step of coding in software engineering is when you actually do it. So this is something that turns testing into a design activity. So you merge testing and implementation and design into one big thing. And we will see that, and that is called the TDD cycle. So tests are written before the code, and this is the closest that you can get to writing the tests at the same time as writing the code, because it is very tedious and to write the test afterwards. And there is something called Leblanc's law. Maybe I didn't pronounce that correctly. It's an American Leblanc. So Leblanc's law is later means never. And many people fall for that, and it is very, very common. So I will write the test later means I will never write the test, really. So do it beforehand. The originator of this idea is Beck. He's a very big figure in the Agile community. So Agile software development is something that has taken off like a rocket the latest decade. Agile software development is based on the idea that I want to be able to react to change. So being able to react to change and taking action when there are new requirements, it's based on the code being able to react to change. And how do I make the code being able to react to change? It's by having very, very, very clean code. It's by investing in the code. Something that is very common and very sad is that when new companies take on newcomers, they drop off these newcomers into maintaining stuff. Outside in the open source community, it is only the absolute best, the experts, that actually maintain software, because they know how it was intended to work. They know how it was written. And if you work with open source, I do that, you know that not anyone can just come and deploy something into open source stuff that is used by a lot of people. You have to work your way up through the ranks. There is a very, very set hierarchy, and you can always suggest something, but that doesn't guarantee that it will be accepted. You have to have a lot of tests and a lot of examples to why your change should make it into the main branch. So this is how it generally works in open source. And in large corporations or large companies, it works the other way around. New people, you go into maintenance because you're not trusted enough to do good stuff. So Ken Beck, he is one of the Agile thought leaders who created the Agile Manifesto. And he also coined the term Agile Software Development and XP, Extreme Programming. I know that some people actually have heard about extreme programming, but we just make a very quick, short reference. Extreme programming is kind of a lifestyle. It has a set of values and some principles and some practices. And at the core of the values, it's just about being a very, very good human being. It is about being humble. It is about learning from others, not being proud in an annoying kind of way, and being generally open to other people's ideas. So XP developers tend to be very nice people. I'm very sure that without knowing it, John Scholes probably is an extreme programmer, actually. I think you all like him. So Kent Beck said that test-driven development, or test-first development, as it was called at the time when he described it, is a way of managing fear during development. It is not a kind of fear that, oh my God, I'm so afraid of everything. It is the kind of fear of, this is a big problem, and I'm not really sure when I will be finished with it. Managing that kind of fear. It is the kind of fear management that it's working, don't touch it. And turning that into, oh, it's working, how do I improve it? That kind of fear management. And you will see how that works. And I have a workshop tomorrow, which I would almost guarantee anyone coming that you will have a laugh, because it's a very, very good workshop on TDD. So it's fear management. It's a very fundamental human thing, having feeling fear, because fear makes us impassive. Fear makes us freeze up, and we do not want fear when we are developing. So there are something called the 3 Laws of TDD, which come from another big Agile thought leader called Uncle Bob, or Robert C. Martin. So Robert C. Martin is the founder of a very, very successful consultancy company where I work with any, almost any, not APL obviously, but any array of languages with very, very high-class people that are very good. They can jump on any project, I think, of any of the common languages and turn that into any success. But they are very expensive. So that was Uncle Bob, just buying credibility from him. So he defined something called the 3 laws, that you may not write production code until you have written a failing unit test. So that means that I do not add any code. I do not make a change in the actual production system until I have a reason to do so. And the reason for doing that is I have a test that is failing. That is the reason. Because if it's actually working and I don't have an actual reason to change it, why am I trying to change it? Why am I trying to add functionality? That's the first premise. You might not write more of a unit test that is sufficient to fail. So when I'm adding a test, I'm adding the smallest possible set of syntactical elements for creating a failing condition. I'm trying to set up the smallest possible example of what we are not able to handle today. That is the thing. I want to prove the smallest possible proof that we have a problem. And you may not write more production code than is sufficient to pass the currently failing test. So I'm only adding the smallest possible change into the system to fix our problem. So if we look at the 3 laws again, that first, I never do add functionality unless we have a problem. And I prove that we have a problem in the smallest possible way. And then I make the smallest possible change for us to handle that problem. So these 3 laws lock the developers into what is called the TDD cycle. And the TDD cycle, like all other good stuff, is also under the law of self-similarity. So the TDD cycle starts by us adding a failing unit test. And we will come to the definition of a unit test. Right now, it's just a test. And we add the minimum amount of code. Then we make the test pass. And we do so by adding the minimum amount of code. And then we come into something called refactoring. I heard the term refactoring here somewhere before, but I do think it was used maybe incorrectly. A refactoring is one small step of source code that maintains the semantics but changes the structure. There are a lot of books about this. I read a lot of books about software engineering and software development. I've read mostly all of them, I think, that are recommended, highly recommended. But refactoring is that we remove duplications and we improve readability. We try to make the system more maintainable. That is the thing. That is the TDD cycle. Now, the self-similarity in this is that when a customer comes in with a new feature request, we add a test for that usually. A test for that feature, that when I call with an emergency number and the system is overloaded, my call goes through at all times. So we add a test for that. So that is the failing test. And then we go into the production code and we start the TDD cycle on all subcomponent parts that are included in this. So there we have the self-similarity. I've heard that self-similarity is very common in nature because good things that work in one level usually work everywhere. So what is a unit test? And this is a rather wordy description, but I think it's the mostly accepted at the moment. A unit test is an automated piece of code that invokes a unit of work in the system and checks a single assumption about the behavior of that unit of work. So the key words here, if you want to just look at something smaller, is that automated piece of code, it has to be automated. You do not want to execute 1,000 unit tests manually. It has to be automated because it is part of XP to value fast feedback. XP developers try to open as many channels as possible to get as quick feedback as possible everywhere. So the fastest feedback you can get from a customer is if you are working with the customer, sitting at the customer site. That is one channel of feedback. Another channel of feedback is the editor giving syntax highlighting, showing where something is wrong. Another source of feedback is running the test to see if I have broken something. There's a lot of different sources of feedback, and good XP teams of extreme developers, they try to set up as many channels as they can cognitively handle in one go, and then they reduce the channels until they feel comfortable. So any help that I can get from anything, any tool, any developer, whatever, I will graciously accept it. Because then I can maximize the time that I'm cognitively using for solving the problem instead of getting trapped in small, ignoring. I mean, I can ignore stuff that doesn't really add value to the customer in any way, and I'm focusing on adding value. Automated piece of code that invokes a unit of work in the system, and this is up for grabs. This is up for anyone with their own system to define what is a unit in my system. Is it 3 functions? Is it 1 function, a defun? Is it a subsystem? I've been doing TDD with a lot of different languages, and when I came to APL, I felt very, very soon that a unit of work in APL was roughly comparable to maybe 5 functions in Erlang. It's about that functionality. It's a semantically very, very strong language in a few characters. So my first style of TDD with APL is considerably different to what it is now. And you will probably feel that at the workshop if you come, which will be a laugh. I guarantee that again. And it checks a single assumption. So you only want to check one assumption in every test. So these are very small tests checking one assumption, because when that test fails, you have the granularity of what is the problem. So you do not need to look at the actual test code. You know by the name of the test what is the problem. So there are some properties of unit tests. If you going formal here, they are small, maximum 2 or 3 lines, absolutely maximum. They only test one thing, one assumption of your system. They use self-explanatory data, and this also comes to the Agile Software Development and XP, and something called clean code. There is the concept of clean code is that I, as a developer, am not only expressing my ideas to the machine, I am also communicating with other developers through my source code. And in that domain, there are a lot of different concepts that are called bad code smells. A bad code smell is something when you look at the code and you can almost smell it. Maybe you can always do that if you are not synesthetic, but a bad code smell, it is a symptom of a deeper underlying problem. And there are a lot of different words. There's a whole language of stuff to learn here that is called coupling, cohesion, artificial dependencies, orthogonality. just to name a few. And XP developers, which I hope that you will all feel that I want to be an XP developer, they have a very good grasp of this. And they are very good, very, very good at expressing themselves to other developers through the source code. Coupled to this, we have practice, which we will come to later. So I'm using self-explanatory data, and I write the code in such a way that I'm expressing myself to you as well as I can. And I can spend a lot of time on this as an XP developer. I can spend 10 minutes, 15 minutes, 20 minutes, an hour just looking at the source code, trying to find the small bits where I can improve it, making it readable, almost making it totally self-explanatory. A unit test also runs quickly. As Morten mentioned, we had a lot of discussions about speed. And unit tests absolutely have to be quick. They have to be under the millisecond almost. I mean, they have to run very, very quick. Because you're constantly building up new tests, because you always add a test first and then a code. And you add very, very small increments of code. So you will have increments of code which are predecessed. Before them comes a lot of small tests. So you're building up a bank of tests, which automatically becomes regression tests for you. So if you have 100, 1,000 of them, they have to be able to execute very quickly. And they serve as documentation. And this is the point of nirvana of TDD, is where you don't even need developer-to-developer documentation. You might need developer-to-user, of course, if you're deploying something. But to other developers within your team or in your company, you only use the tests as documentation, because that is the ultimate form of documentation. That is self-executing and self-checking documentation, where every test is one small use case, detailing how your stuff works. Another thing that Uncle Bob coined was the first principle. He says that good unit tests, they are fast, independent, repeatable, self-checking, and timely. So fast is that they execute quickly. We just talked about that. Independent means that one of them fails. That is okay, because I have a barrage of them. I have 1,000 of them, and none of the others should be impacted by that one failing one. So I can only look at the failing ones and see, okay, this failed, I know why. Repeatable, they should give the same results, no matter if I run it on a Monday, on a Tuesday, at 3 o'clock, at 4 o'clock. I actually found a piece of code in our product that changed the way it was testing the system, dependently if it was a Tuesday. If Tuesday, I honestly found that, and we had a discussion about that afterwards. It is self-checking. If it fails, I have to be able to, with 100% certainty, believe that this is a problem. I shouldn't be forced to rerun the tests. I have seen such tests that you have to rerun maybe 5 or 6 times just to make sure, because it has some timing errors or whatever. It has to be very, very solid. It is also a matter of professional pride delivering that kind of tests. And it is timely. It was written before the actual production code. That is timely. So we're looking at the TDD cycle again. We will take a different interpretation of it. The first interpretation was the formal one. So add a failing unit test is really about externalizing and crystallizing your thoughts. In this mode, you can go into something that I think is also referred to as dreaming in code, I think it is called. That you're actually writing what you would like to see in the future. So you go into wishful thinking. This is how I would like my code to be. And you are the customer of the client of your own code. And you will write the test you would have liked to see if you would look at the test for this particular module or this particular function. Because if this is supposed to be documentation, now is the chance to document it. How is this working? And I will write the test I would like to see. Where we make the test pass, this is just about making it work. And I can commit any sins necessary for this. Any sins necessary. I do not think about performance. I do not even dream about what if. No. The smallest possible code to making this work. And why am I not thinking about doing it properly? Because that is the refactor step. There is where I make it pretty. This is about separation of concerns. You only concern yourself with one problem at a time. The problem I'm concerned with in the previous step is how do I make this work? I am focusing 100% of all my cognitive force on making this work. I can use scotch and gum and whatever. Just hold it together enough to come to the next step. Just make it pass the test, and then whew. And here where we actually make it pretty. So how if necessary, I can think about performance. In essence, you should not feel ashamed if the piece of code you are just finished with was put on display for the whole world to see. That's how nice it would be. That's how nice it should be. And why? Is that really necessary? Yes, it is. Because very, very good developers are paid a lot. And there is a reason for that, I think. It is because they are, in the end, they are actually cheaper. Why? Because there is an economy of scale. There are a lot of studies. I know 3 studies done by Microsoft, for example. I know that you people are very Microsoft bound, so I'm throwing out that word. In the studies, they were looking at how much time does a developer in generally, percentage-wise, spend on reading and writing source code when it comes to maintenance of systems. And when maintaining a system, on average, people spend a factor of 10 to 15 more time reading than writing code. So if it takes me 1 hour or half hour to understand a piece of code, then that is some time spent. That you might think that's okay, but that scales every time someone comes over that piece of code. It is a black hole of accumulation, of stealing time. It is like the Dementors in Harry Potter. It's there sucking you every time you pass it by. You have to cognitively understand that piece of code again and again and again and again. And it happens to everyone passing by that piece of code. So that piece of code is stealing a lot of time. It is soaking time. And time is salary, and salary is money. Someone is paying you for this. So if I could spend another 1 extra hour doing refactoring, making it pretty, making it understandable, making it steal less time, then it pays back very, very, very quickly. If that piece of code takes 5 minutes to understand, instead of 1 hour, instead of 2 hours, there is a huge gain. Especially the larger the company, the bigger the impact. We have 250 developers in our product. All of them are quite good, actually. I wouldn't say that they are brutish. And we think about this a lot because we move around inside the whole system, being able to work at every part, and it's a very large system. So I would implore you to please think about this, about how it scales. Even if you spend 1 extra hour making it prettier, it might end up being very, very valuable for others. Because every time someone passes that piece of code, it will suck a small piece out of their life into itself. Almost finally, TDD, it's a skill like any other, and it must be practiced. And this is where we'll go into talking a little bit about practice. So practice is also a big thing in the Agile community. It is based on the belief that if you practice something, you get better on it. It might sound like a ridiculous belief, but I think it's very, very true. There's a lot of people who work a lot, but they don't practice so much. And you have to compare that with practicing and performing. When I go to work, I get paid to perform. When I'm at Ericsson, I get paid my quite nice salary. That salary is there because I'm supposed to produce something for my company. I'm there to perform. I'm there to perform at my best, doing my best every day, going home and feeling that today I did my absolute best. I did everything I could. To do that, I must be able to practice at least some time. Otherwise, you will very, very quickly hit a level and you will stay at that level. You will never go beyond a certain level of how good you are. For you, it might sound very, very obvious that passionate people, they kind of practice on their own spare time a lot. But there is a huge group of people that also do not think like that. That think that they go to work and I know sufficiently enough to do my work. Why should I practice? Why should I? I know enough to do what I'm supposed to do. But maybe that is okay for you, but compared to others, maybe you are very, very, very bad. And that is also a time trap, because maybe one person can do something in 2 hours, and they think that is normal. because they don't know that they could be doing it in 2 minutes. Not in my team, but another story. I was passing by another team, and 2 people were sitting there trying to work with something, and then one of them approaches me and says, "You know what? I got this file over here from a customer, and I don't know how to unpack it." And it was, I think it was .targz.pc, I think it was. I don't remember the exact extension. And they had been sitting there struggling with this file for quite a while, maybe up to 1 hour, I think. And they had been Googling file extensions, blah, blah, blah. And I said, "Okay, have you tried running the file command on it?" File is a Linux command that says what kind of file it can see, if it can infer the file type. And they run the file command file. "Oh, this is actually an encrypted message from someone." "Oh, okay, there you see. That was 1 hour, 1 second. There's a huge differences like that. And the more that you work with other people that are very skilled, the more you start realizing how big that gap can be. It can be huge. Some people have acquired all that knowledge just through having worked a long time. And I say that that's very good, and you should try to work together with people who have seniority in time because they have seen a lot of stuff. And other people acquiring it very, very quickly through practicing a lot. So in the Stockholm software craftsmanship community, we are 500 developers from a lot of different companies, from banks, insurance companies, Ericsson, and whatever, and a lot of contractors. And we value practice a lot. Because practice, it is the number one thing that takes you to the next level. And it's called explicit practice. So there's 2 types of practice, incidental and deliberate or explicit. Incidental practice, it is the practice that you do without knowing it. You just kind of get better by doing something. And that can take you to a certain level. Deliberate practice is when you actually set off time. 2 hours practicing one thing. What do I don't know so well? What should I know well? And you have to be very, very good at facing your inner demons when you do that. You have to be very, very honest with yourself. If there are any object-oriented developers or any people aspiring to actually be object-oriented developers, I can say that there are roughly 47 design patterns for object orientation that exist for a reason. People have been working with object orientation for a long while. And there are literature about this. So these 47 design patterns, they will dictate and help you how to build software in a very, very nice way using object orientation. There is something called solid principle for object orientation. There is something called object calisthenics. There is a whole world. There is a very, very long list of literature that you should know if you want to be a good object-oriented developer and use classes in a way that they were intended to be used. All of this stuff, very few people know them. If you are willing to face your demons and sit down for 2 hours every week, it doesn't take long until you are very, very good. You just have to be willing. As so, TDD is also a skill. And in the workshop, we will just get going very, very briefly, and you will see how it works. But it has to be practiced. And many companies make the mistake, I think, of start using a new practice or a new tool without having actually practiced on using that practice of that tool. Because you want to differentiate between where you fail and where you succeed, where you practice and where you perform. It is okay to fail in a practice environment because you're trying something new and you're not feeling stressed. So you should want to have a state of mind of calm and focus when you're practicing. You do not want to feel stressed. You don't want to feel exposed. Children are very, very good at learning, actually, because children learn conditioning less. I mean, they are not afraid of failing. When they start walking, they just do it and then they fall and then get up and they fall and then get up and fall. And eventually the feedback system of the body and the evolution of the brain helps them actually start walking. And a lot of people that I see coming to practice session, they are not in that state of mind. And I want to implore everyone that if you set up a practice session at work or at home, don't be afraid of failing. It is okay. It is a practice environment. You are there to practice. Even if you don't even make it through one of the things that you want to learn, that is okay. It is also the journey that is part of the importance. So TDD must be practiced like anything else. I will just mention these references shortly, and then add an extra bit where I will demo something very quickly about TDD. So test-driven development by example, that is from Kent Beck. It is the first piece of text on this. Then we have growing object-oriented software guided by tests. So that book may sound as it is very, very focused on object-oriented developers. Not really, actually. It talks about a lot about the principles and the practices of TDD, which is a very, very good book. Clean Code, a handbook of Agile Software Craftsmanship. I would say that is the recommended reading for anyone wanting to aspire to be a craftsman. And the word craftsman, it sounds very highbrow, and it is intended to. Because the thing is, a lot of people talk about developers as if they are lesser creatures, as if they are code monkeys or whatever. But if I say that, no, I'm a software craftsman, I'm raising the bar. I'm raising your expectations on me. And I'm also raising my expectations on people working with me, which is okay. Because if you want to be respected and you want to have a good pay and a good work, you have to work for that. Nothing comes for free. Anything that you get without making an effort has no value, really. You all know that. You've all struggled with something. The Clean Coder, a code of conduct for professional programmers by Robert C. Martin. Also a very, very good book. It is about what is professionalism, how do you behave professionally. For example, he makes one of the comparisons between surgeons and developers. Surgeons go to work, they have to be at the top of their game every time they're there. They do not behave childishly. I mean, they behave as true professionals and adults, as you would like to if you are paying them. No surgeon would ever, in the middle of a surgery, when something unexpected happens, the conditions have changed, there is a new artery has ruptured somewhere. They will not go, God damn it, I can't work in this environment. I hope so. There are a lot of professions where we expect a lot of professionalism out of people. And as developers, if we want to be respected, we should also behave as professionally as we can. And this is a very good book about that subject. It is very language agnostic. It doesn't mention code at all, almost. It's a lot about personality and how to be. Then we have a link, which you will hopefully find when you find this presentation, from Roy Osherove. Roy Osherove is a very upcoming big name in TDD. And he has a very good definition of the unit test. It is the definition that we saw here. It is basically language agnostic as well. The history of Agile software development is that a lot of this stuff has come out of the object-oriented community, people working with Java and C++, because there are so many of them. And a lot of big developers work in that field. So this is something that you also have to have in mind, that there's a lot of things happening outside of this community, and it is worthwhile, once in a while, to take a look, take a peek, what is happening outside. What are the big names doing, and why are they doing it? So I am not here, as I said, to try and convince anyone of anything. I'm just here to present one of the things that Kent Beck and Robert C. Martin, possibly the two, I think, best Agile developers there are, have said that they are not great developers. They are good developers with great practices. That is what makes them great. They have these techniques, these practices to fall back on when the pressure starts mounting. If you truly believe in XP and TDD and refactoring and pair programming and all that, you're always doing it. And you do it extra. You do it to the 10th level when the pressure starts mounting. The book, The Clean Coder, A Code of Conduct for Professional Programmers, has a very good chapter about that, about handling the pressure, with a lot of stories from a lot of different developers who have been subjected to high pressure and with very high stakes at play. And many of them actually are Agile developers, and one of them mentions that in one project he lapsed and he abandoned the things that he actually believed in. He was trying to develop an application for a well-known American supermarket, where they, for I think it was Black Friday, was going to give people coupons online. And he had 1 week, and he said, yes, I will do it. And then he started coding, and he was just hacking away all night, all day, testing nothing, just getting it done, feeling like the king of the world when he deployed it, and then it wasn't working. There was a bug somewhere. And he said that if he would have just stood by his actual practices and his principles, if he would have been doing TDD and pair programming, that would never have failed. Because it is when the pressure starts mounting, it is then that we need these great practices the most, when we feel stressed. That is the most important time when we need it, to turn us into great developers. Now about a short demonstration here then. So this is the way I execute the tests. So in this unit test framework that we'll be using at the workshop, there are test files, so it's salt scripts under anywhere. I chose to put them under the test directory, as you see there. So inside this directory, I have saltscript.dialog, and they are test files because they are called _tests. That is what identifies a test file. And in that namespace, in that salt script, there are test functions, and they are unit tests. And a test function is identified by the name being whatever _test. And it's a dfun, it can be a tradfun as well, it works very well. Now I have a number of tests here, and I execute them, pressing enter, bam, done. 22 milliseconds, that's acceptable for 15 tests. Every test also gets a short indication of the runtime if there was sufficient runtime to be measured, actually. A lot of them are very, very, very quick, so I can't capture them by the timestamps. And it shows passed or failing. Together with this, we have a coverage report, which is generated for my actual code. And for this example that I just executed here, I don't have I don't have tests for everything to show you the red part. So here we have a coverage 59.45%, 22 out of 37 lines were covered. Everything in green was hit by my test code. Everything in red was not covered, code coverage. Here I see that. And the page was generated at a specific timestamp. So what you want to do when you are doing this is to add a test, and we will look at a test here. So TDD tests in that namespace. For example, this one, display robot heading tests. So let's just, there we go. Oh, the Linux environment, it is so good. The name of the function is display robot headings tests. That is what indicates it as a test function, a unit test. And then I assign what I'm expecting to ut.expect. And then I call my function on something. And if it matches, it is correct. If it doesn't match, it is not correct. So I will now purposefully make one of the tests fail, so you can see what it looks like when they fail. I will choose which one. Let's take this one. I'll remove 1, 2 there. Let's see if it can still save it. I hope so. Oh, dear me. Yeah. Are you taking notes about this? Yeah. So I hope write cannot come quick enough. So once again we'll go in here and we will change the first function. Let's make it easy here. As so. Yes, save that. ut.run. Tests. So if I would have several test files under that directory, they would all be executed. So the idea is that every namespace could have their accompanying set of tests in their own test file. And you could send these to a colleague, just, hey, you have my test file, and just run them with one single command. So it says now 1 failed, 14 passed. Here it is. Display robot headings test failed, and expected empty, and we got this. This is what it looks like when it's failing. Very, very fast feedback. Just what is failing, which test is failing, and what did I expect and what did I get. This is enough. I have written a time booking server using this test framework. And RPM, do you know Raven's progressive matrices? Anyone? Hand up, anyone if they know what it is? Okay, unfortunately. That is an IQ test that generates 9 matrices. And it gives you a sequence with an underlying rule set. And in the last matrix is missing, and you have to say which one is the next logical progression. So RPM, Raven's progressive matrices, consists of both dots that are moving and rotating shapes and stuff like that. And for full disclosure for you here, I've been doing continuously a lot of IQ tests because I did my service. So the 4 suites that are here somewhere, I don't know where they are, whatever. I did my military service in the Army Intelligence, doing programming a lot with IT. Not IT warfare, but closely related. I have a measured IQ of 142. So, if you want to know. RPM, anyway, it's a project, as many others are on GitHub, where you can find this. Now, before I close off here, I would like to mention that in the name of practice, there is a lot of practice you can do without much effort. There is something called katas, stolen from Japanese martial arts, which I know some of you are doing as well. A kata in an agile setting is a problem, a small problem that is interesting enough to get you going, but it is also small and simple enough so you can finish it rather quickly. One well-known kata is the bowling kata. The bowling kata is that you get a scorecard in bowling, a graphical one, and you write a program that displays what is the total score for this scorecard. Not too big of a problem. And you do this using TDD, test-driven development. So you have something that gives you a reason to practice your skills, your practices, refactoring, testing, code coverage, all of it. And the only focus while doing this is on your practices and your principles. That's the important bit. I do a lot of practicing with my teams at Ericsson, and I also develop a lot of katas, which you can find, if you would so like, on GitHub. One of them is a new style of kata, which I developed. It's called an incremental kata, where you get one problem, a very small one, and then you finish that. And then you get a new one without knowing that it existed. And it's kind of like simulating a business interaction with someone, and it's quite nice. There may be up to 10 different steps, maybe not. The thing is that there are 10 files. Each one of them may have a description of a problem, or they don't. You don't really know. You just work your way through them until it is actually done, and that's part of the charm of it, that it is a simulation of a business interaction. That was it, and I hope to see you at the workshop if you can. Yeah, questions. I'm well to say that, I guess.
Okay, so maybe you can answer a question I've had about TDD for a while. The use of tests for design is a fairly appealing task, but one of the things that usually the design maps to some sort of system requirements or features that the user wants. What do you do when you want explicitly to handle cases that are rather complicated in their assumptions and might not actually fit within a unit test? Things like deadlock, freedom, or progress and preservation, or these things which are fundamental requirements of the user. They are the feature that is wanted, but they don't. I mean, are they a unit test? How do you do TDD when that test could be an hour long or something?
I love that question. That's a very good question. And there's now, then we will separate its two conceptual different things. What you are describing sounds more like a function test or a test of the actual behavior of the system. And as such, they are two different kind of animals. I write my unit test to preserve internal quality, to ensure that I get decoupling and cohesion, and that I'm expressing myself very well for other developers. While such tests would actually test external quality of what the customer is paying for. Because as the customer really doesn't give a care for how the code looks, but we care a lot about that.
So you would decouple the tests that you use TDD from the actual set of features that the customer talks.
So the comment was, so you would decouple the actual unit tests from this set of feature tests the customer cares about. Yeah, I mean, they are two different kinds of tests, really. And we accept function tests to take a whole night, perhaps. But what I'm working with inside the system, it has to be a matter of a second of running all the tests. But they do not exclude each other. They complement each other, just like yin and yang.
Gianfranco, thank you very much. Thank you.